This lecture itemizes observations of the moon, which will be explained in the next lecture. Before this lecture, watch the NASA Scientific Visualization Studio movie of the moon and write down your own observations. First, let's look at what the full moon looks like over the course of half a year. Here's what it looked like in January of 2015. February, March, April, May, June, July, and another July. It's a blue moon when there are 2 full moons on a single calendar month, and this has nothing to do with its color. You probably noticed that same side of the moon is always facing Earth, and you probably already noticed the rocking back, forth, and tilting up and down motions. These are called librations. Although at any one time we can see only half the moon, over time 59% of the moon's surface can be observed from Earth due to librations. As we saw, full moons are about every 28 days. Full moons are not the same size in the sky, and the lunar disk is larger in July than in January of 2015. From looking at the full moons, we find the following. The same pattern or side is always facing Earth. There's a slight rocking back and forth. This motion is called libration. The size of the lunar disk changes, although it is very close to half a degree in the sky, and it is a full moon about every 29.5 days. Now let's look at it over the course of a month, every 3 days. There are phases of the moon that are predictable. The same patterns of phases occur between successive moons. The moon's daily path across the sky was not as evident in the NASA visualization, but we'll include it in our observations. The moon rises in the east, traces out a curved path in the sky, and sets in the west. It follows the same path as the sun, the ecliptic, more or less. Let's take a look. As it does, it appears to rotate in the sky. Casual observers of the moon have fooled themselves into thinking that the moon rotates in the sky, and that's why the moon always appears to be flipping. If you stop and think about it, that makes no sense. The moon isn't moving at all much compared to the rate of the Earth's spin. The Earth is spinning on its axis, and that's why the moon's shape rotates along the path. In summary, the moon is the most prominent feature in the night sky. The moon is second only to the sun in apparent brightness among celestial objects. It also appears roughly the same size as the sun. Over time, we can see about 59% of the moon's surface on account of librations, although at any single instant, we can only see 50% of the moon's surface. Over time, we can see a very predictable sequence of changing phases of the moon. We can observe the moon's changing angular size due to the eccentricity of its orbit, and the phases of the moon undergo field rotations, or the shape changes or rotates as it goes.